Good evening, welcome to the STEM Shed. Today I'm going to be discussing a topic you probably heard if you watched the news recently, and that's going to be the COVID-19 virus or disease. COVID is actually part of a disease called SARS, coronavirus 2. SARS stands for Severe Acute Respiratory Syndrome, and then you got coronavirus 2, meaning this is the second one. They also might call it the novel coronavirus. Now, the things about the coronavirus and even like influenza, for example, is they have kind of similar structures, which I have drawn out here, the coronavirus, which I obtained from the American Society of Microbiologists, so they kind of know what they're talking about. And the thing is, this thing is a very easy virus to kill in the surface. Once it's in your body, maybe not so much. And one quick little point I like to point out, viruses comes from the Latin for poison. Alright? So, a general thing about viruses is these right here with the fatty envelopes are actually easy to deactivate or denature. Stomach viruses, on the other hand, have a tough protein shell called a capsid, and that's a lot tougher to get rid of. So, going to here to the RNA, this is what is going to get into your cell and start coding other viruses as they reproduce. So, some of the makeups of, you got the RNA on the inside, you got the lipid bilayer right here, and you have the hemagglutinin, which I believe in influenza actually helps attach to your cell, or attaches to your cell. Here though you have a spike glycoprotein, and I saw through the National Institute of Health from some research done from some people at the University of Texas in Austin, they found a spike protein on here. And this is actually what connects to your cell. So when they get this information, they can use more of it to help find a way to treat it. So, all right. So going back to this, I want to remind you guys what the phospholipid bilayer is. So what I have drawn here is, if you remember this, you had your polar head, and then you had your nonpolar tail. And I drew out the chemical structure because I am a chemist, so I like doing that. And you got the nonpolar tails. So you got the nonpolar tails. Well, and that's important, and that's how they stick. Because remember, they kind of rotate back to each other like this. You got the polar head on this side, and the nonpolar tails, and they go back like this and form a layer. So, and so you have your envelope, which I kind of drew out to look like this. Alright, now if the shell is broken, this virus is useless. The virus needs to actually transfer to your cell without being exposed to the outside elements. So, and lipids are easy to break. You break lipids apart every day in your sink using this. Alright? So, soaps consist of a long non-polar portion, the tail, and the polar portion, the head. That includes the salt. So, for example, sodium lauryl sulfate, which looks like this right here, has a non-polar tail, has a polar head. Guess what? It looks like this over here. It looks like this over here too. Polar head, non-polar tail, non-polar tail. So when you use the soap, what happens is that if you have a piece of grease, which I'm going to represent right here, a piece of grease, and then you have your non-polar sodium lauryl sulfate here, which I'm going to do this, put an S and put the zigzags here. They kind of form a little non-polar tail attracts to the non-polar grease. And then these, of course, I'm going to do blue. And these right here, so non-polar tails, polar head. And these are attracted to the water. Oops, let me do H. H, H. These are attracted to the water. So when you rinse it down the sink, the water pulls this with it, and then this pulls the grease with it. But we don't care so much about that much, as much as we care about deactivating or denaturing the phospholipid bilayer. So while doing that, when you wash your hands, and this is why you gotta wash them for a long time, you actually have to give it a chance to work. I hope to demonstrate this later on with the strawberry DNA extraction, which uses the soap to break the lipid cells apart in the strawberry to get the DNA out. Alright, so if you have a little happy bilayer here, you got these right here, and they're all happy. I'm going to draw this right here. Alright, well, if you have a soap, and that soap goes into it, the sulfate, you got this long chain, alright? It's kind of going, it's going to go in, it's going to work its way into here. And then what happens is that as this goes here, this tail right here is going to start swooping towards the non-polar tail. It's going to start kind of going this way. Alright? So eventually what happens is, as this goes through, this soap has unleashed hell on this bilipid layer, and you now have these chains facing here, and chains facing here, and guess what's going to want to leave this area? The DNA. And you're going to have the DNA that was right here all happy, well now it's going out here to the cytoplasm. And that is not where it wants to be. So this is why it's important to wash your hands. So when you wash your hands, you don't just put soap, go splash, splash, rinse, rinse. You gotta soak it, lather it, let that sodium lauryl sulfate get down in there to those fatty lipid cells of the virus that's on your hands or on the table. And you need to use that to break those apart, because again, once this RNA is out of here, it's useless. It cannot get into your cell. It will never get through. These are very complex proteins that this virus has made that tricks your cell into letting it in. Otherwise, your cell would have this RNA coming to it and be like, nope, ain't coming in. Sorry, not going to happen. So I hope tomorrow or sometime soon to do the strawberry DNA experiment again, except I want to do one where I use soap or where I don't use soap, and one where I just even try alcohol, because alcohol is more so made to, if you sneeze on the table, you got a mucus layer up here. Well, the alcohol breaks apart that mucus and it exposes the virus more so to the air, which is a much harsher environment, or to the UV light, heat, which will cause it to break apart. So the short is, as this is going on, be sure, wash your hands. You know, CDC recommends 20 seconds, not a bad deal. Rinse them, put the soap on them, lather them around, get them going, and then rinse them off, get that virus off of you, so that you at least don't, you know, because what happens if you have this virus on your hand, or you touch a table with the virus, and next you know, you're picking your nose, and that thing has gone right into your severe acute respiratory syndrome. So that's right where it needs to be. It's where it'll be happiest the most. So I hope you learned something from this. And remember, disclaimer, I'm not a doctor, a microbiologist. I'm not a biologist even. I'm just a chemist. Thank you.